Dear students, welcome to another video tutorial on data structure and algorithm. And today's topic is selection sorting technique. Okay. So as you know, in our previous lecture we have discussed about insertion sorting. Okay. So today we will discuss about selection sorting. Myself Niladri Shekhar Pal. I am working as an assistant professor at Computer Science and Engineering Department at Greater Kolkata College of Engineering and the college is under JIS Group Educational Initiative. The college is situated at Bali. Now come to the selection sort. Basically, selection sort in C is used to sort numbers of an array in an ascending order. Okay. With a little modification, it arranges numbers in descending order. Selection sort algorithm is used to arrange a list of elements in a particular order. Okay, it may be ascending or it may be descending. In selection sort, the first element in the list is selected and it is compared repeatedly with all the remaining elements in the list. Okay. If any element is smaller than the selected element, okay, then both are swapped. So the first position is filled with the smallest element in the sorted order. Okay. Next, we will select the element at a second position in the list, and it is compared with all the remaining elements in the list. Okay. If any element is smaller than the selected element, then both are swapped. Okay. So we can say that selection sort is a simple sorting algorithm. This sorting algorithm is an in-place comparison based algorithm, okay, in which list is divided into two parts, the sorted part at the left and the unsorted part at the right end. Okay. So selection sort is a simple sorting algorithm. This sorting algorithm is an in-place comparison based algorithm, okay, in which the list is divided into two parts, the sorted part and the left end, at the left end, and the unsorted part at the right end. Initially, the sorted part is empty and the unsorted part is the entire list. Okay. The smallest element is selected from the unsorted array and swapped with the leftmost element, and the element becomes a part of the sorted array. This process continues, moving unsorted array boundary by one element to the right. Okay. This algorithm is not suitable for large data sets as its average and worst case complexities are of order of n square, where n is the number of items. Okay. So selection sort is used to arrange a list of elements in a particular order. It may be ascending or descending. In selection sort, the first element in the list is selected and it is compared repeatedly with all the remaining elements in the list. Okay. If any element is smaller than the selected element, then both are swapped so that first position is filled with the smallest element in the sorted order. Next, we will select the element at a second position in the list and it is compared with all the remaining elements in the list. If any element is smaller than the selected element, then both are swapped. This procedure is repeated until the entire list is sorted. Okay. So now come to the steps of selection sort. Okay. So in the step 1, we will select the first element of the list, that is element at first position in the list. In the step 2, we will compare the selected element with all the other elements in the list. In the third step, in every comparison Okay, if any element is found smaller than the selected element, okay, then both are swapped. In step 4, we will repeat the same procedure with element in the next position in the list till the entire list is sorted. Okay, okay. So in step 1, we will select the first element of the list, that is element at first position in the list. In the second step, we will compare the selected element with all other elements in the list. Okay. In the third step, in every comparison, if any element is found smaller than the selected element, okay, then both are swapped. Okay. In step 4, we will repeat the same procedure with element in the next position in the list till the entire list is sorted. Okay. Now we'll show you a simple example of selection sorting. Okay, so these are the elements in the array 15, 20, 10, 30, 50, 18, 5, 45. Okay, so elements are not sorted. Okay, we have to sort the elements of the array using selection sort. Okay, so in iteration 1, we will select the first position element in the list and we will compare it with other elements in the list. And whenever we found a smaller element at first position, then we will swap those two elements. Okay, so as you can see that 15 is the first position, so the element at the first position will be compared with the rest of the elements of the array. Okay, and we will do it until we will found a smaller element, okay, from the element that is in the first position. Okay, so we will now search an element which is smaller than 15. Okay, so first 15 will be compared with 20, as 20 is greater than 15, so there will be no change. Next 15 will be compared with 10, so as you can see that 10 is smaller than 15. Okay, so there will be a swap. Okay, so 15 will come to the position of 10 and 10 will go to the position of 15. Okay, so this is the swapping. Okay, after that 10 will be, so now in our first position the element is 10 now. Okay, so 10 will be compared with now 30. Okay, so as 30 is greater than 10, there will be no swapping. Okay, so 10 here you can see that 10 is compared with 30. Okay, and 30 is greater than 10. Okay, so there is no change. Next 10 will be compared with 50, and here 50 is also greater than 10. Okay, so there is no swapping. Next 10 will be compared with 18. Okay, and here also same thing will happen, as 18 is greater than 10, so there is no change. Next 10 will be compared with 5, as you can know that 5 is smaller than 10. Okay, so there is a swapping. Okay, so 5 will come to the first position and 10 will go to the position of 5. Okay, next we can say that the element in the first position is now 5. Okay, so 5 will be compared with 45. Okay, so as we can know that 45 is greater than 5, so there is no change. Okay, so iteration 1 has been completed. Okay, so after iteration 1, what will happen? We can conclude that after iteration 1, 5 came to its final position. Okay, so we will, after iteration 1, we will get the smallest element. Okay, now this is iteration 2. In iteration 2, we will select the second position element in the list. Okay, and compare it with the other elements in the list. and whenever we found the smaller element at second position, then we will swap the two elements. Okay. So in our previous iteration one, we have compared all the elements of the array with the elements at the first position. Okay. Now we will do the same thing with the second position. Okay. So we will compare the second position element of the second position with the rest of the element. Okay. So we will not check 5 as it come to the final position. So here in our second position the element is 20. Okay. So 20 will be checked with all rest of the elements. Okay. So 20 at first will be checked with 15. Okay. So as you can see that 15 is smaller than 20. Okay. So there is a swapping. Okay. So 15 will come to the second position and 20 will go to the next position. Next 15 will be checked with 30. Okay. As you can see that 30 is greater than 15. Okay. So there is no swapping. Next 15 is checked with 50. Okay. So here we also say that 15 is smaller than 50. Okay. Or rather we can say that 50 is greater than 15. Okay. So there is no swapping. Next 15 will be checked with 18. And here is also same thing. 18 is greater than 15. Okay. So there is no swapping. Next 15 will be checked with 10. Okay. So as we can see that there will be a swapping. Why? Because 10 is smaller than 15. Okay. We have swapped it. So 10 is now at the position 2. Okay. So now we'll check all the elements. Okay. So now we'll check whether 10 is greater than or less than 45 or not. Okay. As 10 is smaller than 45, there is no change. Okay. So this is the end of iteration 2. So after iteration 2, 10 come to its final position. So after iteration 2, we got the second smallest element. Okay. We got the second smallest element. Now we will move to the iteration 3. Okay. As you can see that we will find out 10. It is the second smallest element. Now we will come to the iteration 3. See, in iteration 3 we will select the third position element in the list. Okay. And compare it with other elements in the list. And whenever we found a smaller element at third position, then we will swap those two elements. Okay. So as you can see that the third element is 20. So 20 is been checked with 30. Okay. As 30 is greater than 20. Okay. So there is no swapping. Next, 20 has been compared with 50. Okay. So as 50 is greater than 20, there is also no change. Next 20 has been compared with 18. As we know 18 is smaller than 20. Okay. So there is a swapping. So 18 come to the third position. Okay. Now 18 will be compared with 15. As we know 18 is greater than 15. Okay. Or 15 is smaller than 80. So 15 will come to the third position. Okay. Now 15 will be checked with compared with 45. As 45 is greater than 50. Okay, so there is no change. Okay, so after iteration 3, 15 came to its final position. Or rather, we can say that we got our third smallest element. Okay, so now we'll move to iteration 4. In iteration 4, we will select the fourth position element in the list and we will compare it with other elements in the list. And whenever we found a smaller element at fourth position, then we will swap the list of two elements. So at first 30 will be checked with 50. 30 is at position 4. Okay. So as 50 is greater than 30, there is no change. Next 30 has been compared with 20. As 20 is smaller than 30, we can say that there will be a swapping. Okay, so 20 came to its fourth position. Next 20 will be compared with 18. And again 18 is smaller than 20. Okay, so 18 will be swapped. 18 came to the fourth position. Okay, next 18 will be checked with 45. As 45 is greater than 18. Okay, so there will be no swapping. So as we can say that 18 came to its final position. Okay. So after iteration 4, we will find out our fourth smallest element, that is 18. Okay, now we will move to the fifth iteration. So here we will select the fifth position element in the list and we will compare it with other elements in the list, and whenever we found a smaller element at fifth position, then we will swap these two elements. Okay. So 50 is now at the position 5th. 50 will be checked with other elements. So here 50 will be checked with 30. Okay. So 30 is smaller than 50, so there will be a swapping. So 30 came to the fifth position. Next 30 will be compared with 20. As 20 is smaller than 30, okay, so there will be a swapping. So 20 came to the fifth position. Next 20 will be checked with 45. Okay, and 45 is greater than 20. Okay, so there will be no swapping. So after iteration 5, 20 came to its final position, or we can say that we will get our fifth smallest element. Okay. Now we'll move to iteration 6. In iteration 6, we will select the sixth position element in the list and we will compare it with other elements in the list. And whenever we found a smaller element at sixth position, then we will swap those two elements. Okay. So 50 will be checked at position 6. So 50 will be checked with other elements. So at first here 50 has been checked with 30. As 30 is smaller than 50, there will be a swapping. Okay. Next 30 will be checked with 45. Okay, but 45 is greater than 30, so there will be no swapping. So after iteration 6, we can say that we get our sixth smallest element, or we can say that 30 came to its final position. Okay. So now we'll move to seventh iteration. Here we will select the seventh position element in the list and we will compare it with other elements in the list, and whenever we found a smaller element at the seventh position, then we will swap those two elements. So in our sixth position or seventh position, the element is 50. So 50 will be checked with other elements. Okay, and there is only one element is other there, that is 45. So 50 will be compared with 45. Okay, so as we can say that 45 is smaller than 50, so there will be a swapping. Okay, so after this step, 45 came to its final position, and as only 50 is there, so 50 is also came to its final position. Okay. Okay, so all the elements came to its final position. Okay, so now we'll do a C program that will implement the selection shortcut. Okay, so let's do the C program of selection shortcut. So this is our C editor. Okay, so we'll move to File, New, Source. Okay, so we'll take first the library files. Hash include stdio.h, pranaya.h. Okay, these are the two header files. Next we will take the main function, that is int main. Any C program will start executing from this main function. Okay. Next we will take the variables, that is int array. Okay. Next in C D position and then T. Okay. So these are the variables. Okay. Next we will take a printf statement slash n, enter the number of elements. Enter the number of elements. Okay. So in the scanf statement, percentage d, comma, ampersand n. This is the number of elements in the array. Okay. So now we'll take the elements of the array. So printf slash n, enter the elements of array. Okay. So now we'll take a for loop for c equals to 0, c less than n with c plus plus. Okay. And there will be a scanf statement. Scanf within double quotation percentage d, comma, ampersand array I. Okay. So you have, sorry, this will be C. Okay. So we have taken all the elements of the array. Okay. So this part has been completed. Okay. So now we'll find out the minimum element. Okay. In n minus 1 times. Okay. So there will be another for loop for c equals to 0, and c will run up to n minus 1. Okay. And c plus plus. Okay. So here we will take the position variable as c. Okay. So d equals to, again we will take a for loop. Okay. So for d equals to c plus 1. Okay. So position number plus 1, and d is less than n, and d plus plus. Okay. So now if array position is greater than arr d, sorry, arr d. Okay. So we can say that position will be d. Okay. And if position is not equal to c. Okay. So if position is not equals to c. Okay. So we can do the swapping. Okay. So t will be array c, and here array c will be array position, and array position will be t. Okay. So So our swapping has been, or sorting has been completed. Okay, so now we'll do the printf. Okay, so printf slash n sorted elements are. Okay, so we'll take a for loop. So for c equals to 0, c is less than n, and c plus plus. Okay, and next printf so percentage t. Okay, and comma, sorry, comma array c. Okay, so this was the program. Okay, let's save it, run it, and we will explain the program. Okay, so this is selection shot, so selection.c. Okay, okay, so this is our element program. Okay, so these are the variables. This is the printf statement, number of elements. Okay, how many elements will be in the array. This is the scanf statement. This is the printf for taking elements in the array. There is a loop. Okay, c equals to 0, c less than n. Okay, so all the elements are stored in array variable. Okay, so there next there is a checking. Okay, here we can see that for loop and the c is started from 0. Okay, and now the value of position is same as c. Okay, so the value of position is now 0. Okay, so there is a new loop, that is for d equal to c plus 1. Okay, that means we will check. Okay, the our first position is at 0th position, and we will check the element at 0th position with the rest of the elements. Okay, that is why here is another loop, that is d equal to c plus 1. That means if c is the 0th element, we will move the loop from first element. Okay, so if array position is greater than array d, if it is greater than, there will be a swapping. Okay, and if position is not equals to c, okay, so then there will be a swapping. Okay, so the value of array c will be go to the value of array of position. Okay, and after doing this, all the elements will be sorted. Okay, and after that we will print the elements, sorted elements. Okay, so let's execute the program, compile and run. Okay, so suppose the number of elements are 5. Okay, so the array elements are 5, 3, 6, 7, 2, sorry, 72 is there, 4. Okay, so you can see that the elements, sorted elements are 4, 3, 5, 6. Okay, so there is a problem small, that is sorted elements, there is 4 king. Okay, so let's check it once again. Okay, so let's execute it. Suppose the number of elements are 4. Okay, so the elements are 4, 3, 2, and 1. Okay, so as you can see that all the elements are sorted. Okay, so this was our program of selection sorting. Hope you have understood it. So this was our program for implementing selection sort. Okay, hope you have understood it. If you have any doubt, any query, you can write on the comment section, or if you like my videos, you can subscribe to my channel to get all the details. or you can visit www.facebook.com/digitalclassroom to get all the details of my video tutorial. So students, thank you for now. See you in the next video tutorial. Thank you.